Today's goal, today you're going to learn to solve QEs with no linear term. Well, what in the world is a QE? I'm here to tell you right now, that's an abbreviation that's used for quadratic equation. Today we're going to solve quadratic equations that do not have a linear term. All right, that's all fine and good, but what now is a quadratic equation? A quadratic is an equation that has an x squared term and nothing higher. So a quadratic equation has to have an x squared in it, but it's not allowed to have anything higher like an x to the third or an x to the fourth, an x to the fifth, etc. Okay? Let me flip this paper over real quick. Here on the screen are 5 equations. 3 of them are quadratic. 2 of them are not. Take a look at this. Hit pause right now. See if you can figure out which ones are quadratic. And here you go. First one does not have an x squared. Not quadratic. The second one does have x squared and nothing higher. That is quadratic. The third one, it does have x squared, but it has something higher. It has an x to the third. Not quadratic. The fourth one has x squared. Nothing higher. And the last one has the x squared. Nothing higher. So hopefully these are the 3 that you came up with. Now, not every quadratic equation has to be written in this order, in this particular order. But when it is, when you have a quadratic equation that's in this particular order and set equal to 0, we say that the quadratic equation is in standard form. So in standard form, the equation is always equal to 0. And then you should know some of these words. This 10 right here that does not have an x at all, that is called the constant term. The 4 that has just a normal x, you could call it an x to the first power. You've already learned this. This is called a linear term. Okay, so these 2 terms should be familiar to you. But then this last term that has the x squared, that's the term that we call the quadratic term. And the quadratic term, it's the one that has the x squared. The linear term has the x, and the constant term does not have a variable. Now, what you're going to find, we're going to solve quadratic equations today. What you're going to find as a guarantee is that all quadratic equations, all QEs I'm going to abbreviate, have 2 solutions. And there's times you might challenge me on this, but this is always going to be true. Every quadratic equation that we solve, and we're going to be solving a lot of them, they always have 2 solutions. So I've got 3 examples for you today, and let's look at number 1. 2x squared minus 72 equals 0. Now we know this is quadratic. It's got the x squared and nothing higher than that. But you'll also notice it's kind of hard to say whether this is in standard form or not because it's missing something. So remember, here's the standard form of a quadratic equation. Well, this is kind of in the proper order, but it's missing a linear term. This equation has an x squared, but it doesn't have an x term. Okay, so go back to our goal for a second. This is a quadratic equation with no linear term. And the way you solve these these are probably the simplest of all quadratic equations to solve. Here's what we're going to do. We're going to start, in this particular case, we're going to start by adding the 72 over to the right-hand side. And we're left with 2x squared equals 72. And then we're going to go ahead and divide the 2. Okay, and notice we're doing this very similarly to how we would solve a linear equation. We added 72 to both sides, and then we divided both sides by 2, and we're left with x squared equals 36. Now our last step then, at this point, hopefully you can kind of figure out in your head that the answer is going to be 6, because hopefully you know that 6 squared is 36, or that 6 times 6 is equal to 36. But the algebraic way we're going to handle this, the opposite of squaring a number is taking its square root. So what we're going to do here is we're going to take the square root of both sides of this equation. Now when you square root an x squared, this is very important. When you square root an x squared, that just comes out to a normal x. I'm even going to make a note of this. The square root of x squared is equal to x. And that's one little fact that's going to come up again and again throughout this unit. So the square root of x squared is equal to x. And now we have the square root of 36. Now a lot of you know that the answer is 6. But here, let me put it in my calculator to show you. The square root of 36 is 6. X equals 6 is a solution. I'm going to circle it. Now time out. Wait a second. Isn't that kind of contradictory? Here I just wrote down this answer, x is equal to 6. What did I just get done saying like 2 minutes ago? All quadratic equations have 2 solutions. So what gives? I only wrote down one answer here. I wrote down this answer of 6. Okay, well here's the deal. We know that 6 times 6 gives you 36. And so it's one of our answers. But can you think of any other number that you could times by itself that would also give you 36? Guess what? There is. It's negative 6. Think about negative 6 for a second. What would happen if we took negative 6 times negative 6? Well, that would also give us 36. And as a matter of fact, not only does 6 squared give us 36, but so does negative 6 squared. Now you have to put in parentheses like this to make it happen. But negative 6 squared also equals 36. Okay, here's the deal. Did you know, when you take the square root of 36 in your calculator is only going to give you one answer. It's going to give you a 6. But the 6 here is called, it's really just one of the answers. It's actually called the primary square root of 36 is 6. But there's another answer that the calculator doesn't tell you, and that's negative 6. See, the square root of 36 can also be negative 6. And this is called the secondary square root. And your calculators are only designed to give you the primary square root of positive 6. It's our job to know that the square root of 36 can also be written as negative 6. That's called the secondary square root. And so a problem like this is going to have 2 answers. One of the answers will be the primary square root of 6, and the other will be the secondary square root, which is negative 6. And guess what? We have to write them both. Okay, either one of these numbers would work, and I can prove it to you. Not only does 2 times 6 squared minus 72 equals 0, which it does, but the same is also true of 2 times negative 6 squared minus 72. It also equals 0, so we need to write both of these down. All right, so there's our answers, 6 or negative 6. All right, on to number 2. So number 2, we're going to add 5. Same type of deal. We're going to add 500 to both sides. We get 5x squared is equal to 600. We're going to divide both sides by 5. And x squared is equal to 120. Double check my math here, but 600 divided by 5, 120. Take the square root of both sides. X is equal to the square root of 120. Oh, but wait. 10.954, this is an irrational number. This is the type of number we just learned about in the last lesson. Now what we can do, we're going to actually round this here. What I'm going to tell you to do on irrational numbers, just to make life easy, we're going to round to 3 decimal places. That's called the nearest thousandth. We're going to say x, and I didn't use an equal sign here. I used this squiggly equal sign. This means x is approximately equal to 10.954. Although, remember, it can also be negative. This is called the primary square root, but it can also be negative. This negative square root would work as well. Okay? Go ahead and try number 3 on your own. It's trickier than it looks. Go ahead and give it a shot. Hit pause right now and give it a try. A little tricky, right? Hopefully you gave that a shot, and I'm curious to see what you did with it. So here, we would subtract 20 from both sides, get negative 16. Divide both sides by 4, we get negative 4. So we get this x squared is equal to negative 4. So we take the square root of both sides, right? Well, what happens? You try to take the square root of negative 4, we get an error in our calculator. So hopefully you were paying attention to the last lesson What are we supposed to do when we get the square root of a negative number, the square root of -4? Okay, well, what you're supposed to do, what you're going to do is you're going to take the square root of the positive number, square root of +4 is 2, and then you're going to put an I on the end of it. Okay, in one case, we're going to say that x is equal to 2i, although we also know it can also be equal to the negative version of that, -2i. Now, look what happened in these three examples. The first one, the square root came out perfectly. The square root of 36, it comes out perfectly. Remember, these are called rational solutions. And with rational solutions, there's nothing really unique you have to do. Just write down the answer, 6 and -6. Easy enough. That's the square root of a perfect number comes out rationally. Now, the square root of an imperfect number, like the square root of 121, does not come out perfectly. These are called irrational answers. And each teacher will have you handle these a little bit differently. But what I'm going to tell you to do, round to the nearest thousandth. Round to 3 decimals. That's what I would like you to do if you ever get irrational answers. And in this last case, when you have to take the square root of a negative number to solve your equation, these are called imaginary solutions. And what do? You're going to take the square root of +4, which is 2, but then you're going to stick an I onto the end of your answer. That's what we do in imaginary situations. And I hope you see how this is tying together. Once you start studying quadratic equations in math class, that's when you start getting into these scenarios where some of your answers are rational, some of them are irrational, and some are imaginary. So that's why it's good to be able to kind of categorize what type of solution we're getting to these different types of equations. All right, so with that in mind, I wish you the best on your assignment. As always, message me if you need any help. Bye.